Good morning. I'm Tony Nadlin from Microsoft. So I run the technical standards in Microsoft from an identity and security perspective. And I'm going to take you through the FIDO2, what we've done in FIDO2, and what Microsoft has done as far as implementing FIDO2 is concerned. Okay. So to look at the big pictures, we'll look at the standards. We'll look at the interactions and the interoperability that has been taking place. So the first thing is, on the standards part, is to understand how FIDO2 works. And there are two specifications that define the abstraction layer to create the identity, to create the ecosystem for strong authentication. First, we have the client to authenticator protocol, CTAP for short. This specification resides or lives at the FIDO Alliance. Work is done in the FIDO Alliance on this particular specification, and it's in proposed standard status today. CTAP defines wire formats and data structures, and we'll go over that a little bit later. We also have the web work, which is the Web Authentication API, WebAuthn for short. This specification lives at the W3C, and its status is proposed recommendation. So, as Brett said earlier, it's in candidate recommendation. We have submitted for proposed recommendation, which is the final step in making this a standard. There are some questions that need to be resolved, but we expect to have a standard by the end of the year in the W3C. This defines the JavaScript API, the wire formats, and data structures. So together, these two specifications are the basis for FIDO2. So to understand the specifications, I'll take you through what I would call the cast of characters. These are things that you need to understand as far as the specifications are concerned. We have relying parties and clients. Relying parties are web or native applications that actually consume the strong authentication. Native applications running on a client device can also act as a WebAuthn client to make direct calls to WebAuthn, which once again is the JavaScript API. Web applications that consume the authentication cannot directly interact with the WebAuthn API. They must broker through a browser. Okay, so the browser would be the way that these would actually happen. We also have client devices. Client devices are actually the hardware used for strong authentication. So these could be laptops, phones, dongles, etc. We've also introduced the notion of platform authenticators. And platform authenticators usually reside on the client device themselves and can't be accessed via cross-platform transports like HID or USB, NFC, or BLE. These are usually built into the laptops or tablets or whatever devices that you use. They can be fingerprint readers, facial recognition, etc. So in Microsoft's particular case, every Microsoft device, certified Microsoft device, has a TPM chip. And the TPM chip is the platform authenticator for Microsoft products. Roaming authenticators can connect to multiple client devices, and they must be negotiated over a supported transport protocol. Some of these are USB security keys, things that you'll see. Some of the authenticator vendors make these. They can be BLE-enabled smartphone applications or NFC proximity cards. What we see today in the marketplace are devices that are actually incorporating all three types of protocols. And so you'll have a device that can either be a USB key, can do BLE, or could do NFC. And they can support the Client to Authenticator Protocol version 1 or Client to Authenticator Protocol version 2. They support both of these. And we'll talk a little bit about the difference between CTAP 1 and CTAP 2 in a minute. So the list of certified authenticators can be seen at this particular address. And if you go there, this is what you'll see. You'll see a list of all the FIDO authenticators that are out in the marketplace today, the ones that have passed the certification. And so the last cast of character that we have is the CTAP 2 platform itself. It's part of the client device that negotiates with the authenticator. Most importantly, it's responsible for the origin of the request. So you've got to understand that that when the request comes in, we've got to make sure that we have an origin of the particular request that came in, and we have to honor that origin. This helps prevent the spoofing of the request. And so if you look at the web authent APIs, we use the top domain level +1 as the origin of the request. And so you can't have other people interject yourself into the JavaScript stack and asking for this. We also support compact binary requests, CBOR. So if you look at JSON can be very verbose, and we've compacted that in using CBOR as the mechanism. And so everything that goes over the wire is in CBOR, and therefore it will be very compact for things like BLE or NFC types of devices that need to preserve some of their power sources. And so this is what the picture actually looks like. If you take a look at the specifications, we have the WebAuthn relying party. That's the piece that actually delivers the JavaScript piece. And so, of course, this piece had to be standardized, right, because we're talking to many different browsers. And so the relying party has to be able to write that JavaScript once and have it delivered to any browser that you're operating on and have that JavaScript use the same set of APIs. It will go into the WebAuthn client, which is sometimes the browser itself. It can also have a platform WebAuthn API, which will actually transform the JavaScript request into native platform requests. And so on Windows 10, it turns into a Win32 API in the kernel. And so the WebAuthn platform API comes in, and we have corresponding native APIs underneath the covers that actually do the work. So it's not written in JavaScript. And so you can be assured of where it's running. It's running in a secure kernel area within Windows 10. So you have no chance of this code actually being stolen. We also have ways to interact with a roaming authenticator. And the roaming authenticator, once again, could be a USB device, a dongle, a telephone, BLE, NFC type of interface. And so the interactions, what we have is basically a many-to-many set of interactions. The relying parties and clients can interact with as many authenticators on a single client device. And so if we go back to the client device, so we can, if you look at the client device, we can interact with many roaming sets of authenticators. We can interact with one platform authenticator, but we can talk to many roaming authenticators in this particular case. Users can install as many browsers that support WebAuthn as they like. We have Chrome, Edge, and Firefox. And if we look at a lot of the mobile browsers that are out there, a lot of them that run the Android are, a derivative of the Android base. And so you get the same effect as what Chrome has. And so you can see Safari's work here. This is, as Brett mentioned earlier, this is the WebKit work. Means that they're actually implementing it. I can't speak to when they will announce or anything, but you can see their work behind it and the status that they've gotten to. And so basically they are at the same status that the other browsers are at, Chrome, Edge, and Firefox. It's just not been a specific announcement by Safari as of yet. And they have access to many authenticators. And so the interactions is basically, if you depends on which browser you want to use. If you've got cases where you want to use Edge or if you want to use Firefox at the same time, you can download them both. They'll both wind up supporting the same set of JavaScript APIs, and therefore you get WebAuthn support or FIDO2 support. Interoperability. So before WebAuthn and CTAP2, there was U2F and CTAP1. U2F has the capabilities of second factor authentication. Therefore, it has a little bit different set of protocols than FIDO2. FIDO2 was, a passwordless based mechanism. And so what we've done in WebAuthn is to be designed to be interoperable with CTAP version 1 and authenticators from U2F. Which is important here is authenticators may support keys for multiple accounts stored on a per-relying party, client PIN, transactional approval, and HMAC secret. The client PIN is used in a lot of cases where you have a platform authenticator and you need to unlock the platform authenticator, so a PIN would be used. Other instances are that platform authenticator may take a biometric of some sort, a facial recognition, a fingerprint, or some other means. The HMAC secret becomes important because of offline scenarios. So not everybody is always connected to the web. And so we need to be able to support FIDO authentication in an offline scenario where you don't have internet access. And in case you want to log on to Windows 10, you want to log on to Android, these would have to support the HMAC secret. So far, what we've accomplished is we've converged the CTAP specifications and WebAuthn APIs. So what this means is that when you want to write a native application that supports CTAP, that same application would speak the same data structures as the WebAuthn API itself. So both of these specifications are in lockstep. By that I mean they both support the exact same data structures as the other ones. We have platforms that have been implemented. We have Windows, Mozilla, Chrome, and Android. So we have the base platforms plus the web platforms. We have implementations of CTAP external authenticators that exist. I think if you go to the Certified Authenticators page, you'll see the FIDO2 authenticators that have been certified. There are quite a few of them. We've conducted many successful interop tests, and that's one of the criteria that we have to accomplish before we finish the W3C work. They want to know whether the specification is actually implementable and whether it's interoperable. So we believe that in first quarter 2019, that critical use cases can be deployed in the wild by any ERP. By that I mean we believe by end of first quarter 2019 that you'll have all the platforms supporting the FIDO2 protocol. So what the standards work has done is allowed us to enable these sets of use cases. Second factor authentication, that is, a user has a password, but it's not enough to sign in. And so that would in turn ask for a second factor, which would be a FIDO authenticator. And these are standardized. This is part of the specifications in FIDO and the W3C, so both in CTAP and in WebAuthn. It's implemented by 3 browsers. We have it on Windows, Linux, Chrome OS, OS X, and Android. And once again, we've done interops on this particular use case. We have the reauth, which a user can use a password, but FIDO is faster on this device. And we have it implemented on Windows and OS X and Android. And then lastly, we have the first factor authentication, which the user has no password, and this is the FIDO2 standard, which is in FIDO and W3C. So as we wind down the work in the W3C, W3C has what I would say levels. We have finished level 1, and people are asking for enhancements to what we've done with WebAuthn. So these are the possible future enhancements that we may consider in WebAuthn level 2, which would be about a year or plus out to complete if we decide to do these. So right now there's a need to install a custom app or binary for biometrics management. That is, every device, every external authenticator or platform authenticator that has biometrics has to provide an application to actually manage those biometric authenticators. That is, to add, remove fingerprints to the authenticator or retina or templates and stuff from the authenticator. So we're possibly looking at an API to actually add, remove this. We supply an API for PIN management, but not for biometric devices. We also need a way to manage resident credentials. So one of the changes that was made with FIDO2 was that we added the notion of resident authenticators. So resident key authenticators. So if you look at U2F, the universal secondary authentication factor, they don't store the keys on the device itself. They are encrypted and they keep sending back over the wire back and forth. What the FIDO2 authenticators do is actually store the key pair on the authenticator themselves. And so, once again, you would need an API to be able to manage those authenticators, to be able to add, to be able to delete various keys that exist on the authenticator. So some platforms have APIs to manage the TPM chip. You can reset the TPM chip. You can do things to the TPM chip. And instead, we would like to see if it's worthwhile to provide an API to manage those sets of credentials, those resident set of credentials. We're also looking at enterprise features. There are a lot of enterprise features that would like to use SSH. And so when I'm managing various servers, it would be nice for me, in a virtual environment, if I have multiple VMs, virtual machines running, I would certainly like to log on to my main machine and have that authentication carried through to the actual virtual machine. Okay, so I don't have to use a password or use SSH without a FIDO authenticator. So we're looking at how we can actually use things like SSH with FIDO. And then lastly, we're looking at authenticators supplying their own supported transports. We realized that, that NFC, BLE, and USB may not be the end-all to be-all protocols. There are some other types of devices, the Zigbee and some other things that are out there for IoT devices that would also like to be able to use FIDO2. So we're looking at how we can actually support other transports for things like IoT. So that's what we've done as far as the standards are concerned. I would say that they're pretty much wrapped up for what we've done, and that there are some future enhancements that we're consider making. But I think, as I said before, 1Q 2019 will be the deployment time frame for all of this stuff. So with that in mind, I'd like to take you through what Microsoft has done in this particular space. So the implementation. It's been 4 years in the making. Introduced the idea of FIDO2 to the FIDO Alliance in 2014. We realized that we needed to get platform support in order for this to be ubiquitous across platforms. Being in this space for quite a while, we realized it's very hard to deliver these features through, add-ons, through clients that you have to download. There's all sorts of security issues associated with that. We wanted to make sure that FIDO was baked in, was actually implemented in the platforms themselves and not add-on. So during this 4-year period, we've refined, improved, and enhanced this notion with the major platform vendors and authenticator vendors, and came up with what's now in the WebAuthn and CTAP work. And so in the Windows 10 October release, which just came out a few weeks ago, we actually support WebAuthn candidate release and the CTAP proposed standard release. So if you have the Windows 10 October release, you have FIDO2 support on your Windows device. Microsoft also introduced the WebAuthn Relying Party. And so this is the logon services for Xbox, Skype, Outlook, and many other services within Microsoft. So our WebAuthn Relying Party now supports FIDO2. Authenticators must have the following capabilities. So if you wanted to be a authenticator for Microsoft Windows, you'd have to adhere to these 4 following conditions. That is, keys must be stored locally on the authenticator and not a server in the cloud. So that means that they must support resident key credentials. Offline scenarios must work, which means the authenticators must support the HMAC secret extension that I talked about, which allows us to do authentication when you're not connected to the internet, right? Because FIDO protocol is a peer-to-peer situation where you wind up doing authentication to a FIDO server. If that FIDO server is offline, you're not going to get authenticated. So we needed a way to actually do the same exact authentication, but be local. So if you go back to the scenarios that I talked about, you'd see how this would be done, which is we can actually make a client device become a FIDO server itself. And so this will actually go through the exact same protocol as a normal FIDO authentication. It's just done locally. Users must be able to put keys for multiple user accounts on the same authenticator. So that means the authenticator has to be able to support multiple keys for multiple relying parties, is basically what this means. And authenticators must be capable of unlocking a TPM with a client PIN protocol or a client biometric device. So remember, the TPM in a Windows case is just an authenticator. It needs a way to be able to be unlocked. And this can be either done through a PIN or a biometrics. The Microsoft account, which is our WebAuthn relying party, will not accept CTAP 1 or U2F protocol. Okay, it's slightly different. Remember, the U2F protocol is a second factor protocol. It's not a passwordless protocol. Edge. Edge is Microsoft's browser. It's our WebAuthn client. Edge actually handles the UI interface between WebAuthn and CTAP. It supports the App ID extension for interacting with CTAP 1 and CTAP 2 authenticators. It supports the creation and usage of U2F and FIDO2 authentication. Once again, it does not support CTAP 1 protocol. Relying parties must use WebAuthn, and Edge on Android does not support WebAuthn as of now. And if you look at this particular URL that's up on the screen, this is the Microsoft Dev post on actually how to use FIDO2 with Windows. And basically, what we have is we have Microsoft's WebAuthn platform, which is the Win32 platform for WebAuthn APIs. Once again, I talked a little bit about this earlier, which is the WebAuthn APIs are JavaScript APIs. They have to be realized by some code within the kernel. And this is the Win32 platform actually does that. They are kernel APIs that are called from within the WebAuthn API. So if we look at what Microsoft has done, this is the picture, which is we have Microsoft account, which is our login service for 98% of all the services that Microsoft provides. It can talk to the Edge, it can deliver JavaScript to the Edge browser, okay, and talk to the native, talk to the platform WebAuthn API, which is the Win32 APIs, okay, which will then talk to the platform authenticator or Windows Hello. So there are two exposed interfaces within Windows 10. That is the JavaScript API through WebAuthn and the Windows Hello API. Okay, the CTAP interface is not exposed in Windows 10. We elected to have everybody use the Windows Hello platform because the Windows Hello platform is a framework for plugging in Authenticator. So this is how, if you are an external authenticator or a platform authenticator, how you actually plug into Windows 10. And currently we support USB, NFC, and BLE is in a beta, and is in a sort of beta state right now. We're working on some things. For instance, I have a ring that we've been prototyping, which is a biometrics ring, which is it talks BLE and it monitors my heart rate. And so every heart rate has a signature pattern. And so that signature pattern is known to me of how my heart beats. And so this allows me to use it to log on to my Windows device at work. And so I use this as a means of authentication. So you can see that these devices are starting to get varied as far as, you know, what they provide. It's also what I would call a fitness, whatever you call this, you know, for doing exercises, running, jogging, walking, whatever. So it also monitors all that stuff at the same time. So these devices are getting very compact and very smart. And so you can, you know, see that the roaming authenticators that we would wind up supporting would support the USB, NFC, and BLE protocols at this particular time. So that's a summary of what Microsoft has produced and in production, and you can go to the web developers page that I pointed you to and look at how Microsoft has implemented FIDO2 and how to actually enable it on your Windows 10 platform if you have the October release. So with that, I'd like to thank you for your time on this particular topic. Thank you.